What are the specific analogs of Prussian blue that have been explored, such as K-Fe2, CN6, and MnFe, and how do these materials compare to other cathode materials in terms of their performance in Na-ion batteries? How does the iron 3 system Fe2, CN6 without alkali metal ions behave in Na-ion batteries, and why is it of interest as a cathode material? What is meant by reversible capacity, and how do Prussian blue and its analogs perform in terms of reversible capacity in Na-half cells? What is the range of reversible capacities for these materials, typically between 80 and 120 mAh per G, and what does this indicate about their suitability for energy storage in Na-ion batteries? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? What voltages in the range of 3 to 3.5 V do these materials operate at in Na-half cells, and how do these voltages influence the performance of Na-ion batteries using Prussian blue or its analogs as cathodes? How does the Prussian blue analog Na 1.92 Fe2, CN6, also referred to as Prussian white, compare in performance to other cathode materials? And why is its discharge capacity of 160 mAh per G at low rates particularly noteworthy? What is the significance of good rechargeability in Prussian white, and how does this characteristic make it a potentially viable material for Na-ion batteries? What challenges or drawbacks are associated with Prussian blue and its analogs, and why is their low density considered a limitation in the context of Na-ion batteries? How does the low density of Prussian blue with a value of 1.8 G/cm superscript 3 affect the volumetric energy density of Na-ion batteries? How does the volumetric energy density of Na-ion batteries using Prussian blue compare to those using transition metal oxide cathodes with the same specific capacity in mA/G? And why is this difference significant when considering practical applications? What role does density play in the overall performance of Na-ion batteries? And why is it important to balance both specific capacity and volumetric energy density when designing battery materials? What further research might be needed to address the density issue in Prussian blue and its analogs? And how could these materials be optimized for higher energy densities in future Na-ion batteries? What materials have been commonly used as anode materials in Na-ion battery research? And why has hard carbon been the primary choice in most studies?